Hello, yes, and welcome to our Objective 1.4 sample problems where we're going to work to identify if a function is even, odd, or neither. So let's dive right in right here. F of x equals 5x minus 6. Let's start by writing the negative f of x, which would be negative 5x plus 6. Remember, all the signs change. So now let's do the test. So f of negative x would be equal to 5 times negative x minus 6. Well, a negative times a positive would give me a negative, so I'd end up with negative 5x minus 6. So f of negative x would equal negative 5x minus 6. Now, is that the same as f of x, 5x minus 6? Nope, because this is negative, whereas this is positive. Is it the same as negative f of x? Negative 5x plus 6, negative 5x minus 6. No. Okay, so here's an example. It's not the same as f of x. It's not the same as negative f of x. So it's not even. It's not odd. This one we would say is neither even nor odd. And if we think about the graph of it, that kind of makes sense. Think about 5x minus 6. That'd have a y-intercept of negative 6. And then it would go up 5 and right 1 all the way up this graph here. Now, we can see clearly by looking at this line that we don't have y-axis symmetry. It's not the same. And we don't have origin symmetry. I can't rotate it around the origin. So this one is definitely neither. We can be pretty confident with that. All right, let's try letter B. 3x squared minus 4. So that means that negative f of x would equal negative 3x squared plus 4. Switch all the signs. Let's perform the test. F of negative x equals 3 times negative x squared minus 4. So for this one, I'd do the exponent first. So a negative times a negative would give me a positive. So I'd end up with just positive 3x squared. Nothing changing with that minus 4. That's what f of negative x would equal. Now, does that equal our original f of x, 3x squared? Yeah, it does. So we can take care of this one pretty easily. F of negative x would equal f of x, which tells me that this is an even function. Now let's look at the graph to see if that's what it shows there as well. Here's our graph of 3x squared minus 4. Notice definitely symmetric to the y-axis. So we have that y-axis symmetry, so we can be pretty confident that this is indeed even. Let's go ahead and sketch a graph. It went down to negative 4, and then it was pretty thin on its way up. There's a pretty rough graph with that y-axis symmetry. All right, let's try letter C here. X to the 5th minus 3x squared plus 7. Okay, so that means that negative h of x would equal negative x to the 5th plus 3x squared minus 7. Switch all of the signs. All right, so plug in negative x. When I do that, I would get negative x to the 5th minus 3 times negative x, parentheses, squared, and then plus 7. So a negative to the 5th, so negative times negative times negative times negative times negative would indeed end up being negative x to the 5th. I do my exponent here first, so this will become positive x squared, so it will be negative 3 times positive x squared, so this would stay negative 3x squared, and then no change in the plus 7. And that is what h of negative x would simplify to. Okay, so does this match the original? No. Does it match negative? Almost, but it doesn't, right? Notice how this is positive where this is negative. Okay, so it is not the same. It has to be the exact same. So it doesn't match h of x or negative h of x, which means that this is a neither function. Let's check the graph of this one to make sure we don't have y-axis symmetry or origin symmetry. So here's the graph of x to the 5th minus 3x squared plus 7. Notice, definitely don't have y-axis symmetry. If I did, we'd have a little dip down here and go up, or this parabola would, or I mean, it's not a parabola technically, but this parabola-like shape would just continue straight down. So definitely don't have y-axis, definitely don't have origin. If I spin this around the origin, I'd get a totally different picture for this graph, which tells us that our assessment of this being neither is accurate. All right, let's go ahead and sketch a graph to show that this is indeed neither. We ended up looking a little like that. Here's a very rough sketch. There we go. Neither. Awesome. Last one, letter D. 3x to the third plus 2x. So that's f of x. Negative f of x would be negative 3x to the third minus 2x. All the signs change. Let's perform the test. F of negative x equals 3 times negative x to the third plus 2 times negative x. All right, so simplifying, negative x to the third will give me a negative. So this will become negative 3x to the third. Positive times a negative gives me a negative. This becomes negative 2x. And I can see that this is going to match negative f of x. So f of negative x equals the negative f of x. And now I can say confidently that this is an odd function. Let's go ahead and graph it to double check that. Here's our graph of 3x to the third plus 2x, and sure enough we can see that this indeed has origin symmetry. If I rotate it 180 degrees, it'd fall right back on top of itself. We can be pretty confident then with our assessment that this function is odd. So back to the graph, we can sketch a rough, looks like that about. There we go. That odd function, symmetric to the origin, and that's it. We're done. Hopefully you were feeling more confident about even, odd, or neither functions. If you have any questions, as always, reach out. Otherwise, go ahead and get started on those practice problems. This is Mr. Carter signing off. I'll see you next time.